Now let's take a look at example 3, where we're actually going to use our factoring skills to solve a polynomial equation. But this particular equation will involve a perfect square trinomial. So the original equation is x squared plus x plus 1/4. We're going to use a technique called clearing fractions. Fractions are more difficult to work with here. So if we multiply each side by 4, so that would look like this. I'm going to multiply all of this by 4, and I'm going to multiply this side by 4. Of course, 4 times 0 is just 0. Over here, we're going to end up with, using the distributive property, 4x squared plus 4x, and of course, 4 times 1/4 is 1. Now what we see is we have a perfect square trinomial. If you look at the first term, 4 and x squared are both perfect squares, and of course 1 is a perfect square. I think we're going to just skip this next step and keep it simple. So what we know, and because this is all addition, is that this is the result of squaring the square root of 4x squared, which would be 2x, plus the square root of 1, which will be 1. Now, this equation has two identical, it says right over here, two identical solutions because the factors are identical. So we know that 2x plus 1 times itself, 2x plus 1, equals 0, because that's the way the equation was set up. But we only really have to solve for 0 once. We know that 2x plus 1 has to equal 0. And solving for that, if I subtract 1 from each side, I would get 2x equals negative 1. Dividing both sides by 2, I'm going to get x is equal to negative 1/2. So x is negative 1/2. We've solved for x. Moving on to example 4, now we're going to use that same kind of skill to solve one of those vertical motion problems. So I'm going to read it first. It's about a falling object. A brick falls off of a building from a height of 144 feet. I hope nobody else is down below. After how many seconds does the brick land on the ground? We're going to use our vertical motion model, which we learned or used in previous lessons. So the solution is to use the vertical motion model. The brick fell, so its initial vertical velocity is 0. It really didn't have, there wasn't somebody throwing it up in the air. So there's no velocity throwing it up there. We're going to find the value of time, t, in seconds, for which the height, h, in feet, is also 0. We want to know when it hit ground 0. So our vertical motion model is h is equal to negative 16t squared plus vt plus s. So negative 16 times the time in seconds squared plus the vertical velocity times the time in seconds plus the starting height or initial height. We're going to substitute in the values that we have. We want to know when the height was 0, negative 16. We don't know the amount of time. We're looking for that. Plus the vertical velocity was 0, so we would say 0t, plus s is 144. Now, of course, 0t, 0 times t is 0. So this really is a binomial. What we're left is with is 0 equals negative 16t squared plus 144. All right. So our next thing to do would be to see if there's anything we can factor out. Negative 16 and 144 probably have some common factors. Let's take a look at what those might be. Sometimes it helps to just look at the prime factorization of a number or both numbers. For example, let's just break this into 2 times 8, 4 times 2, 2 times 2. So the prime factorization of 16 is 2 times 2 times 2 times 2. 144 can be broken into 12 times 12. And 12 times 12 can be broken into, 4 times 3. And the 4s can be broken into 2 times 2. So the prime factorization of 144 would be 2 times 2 times 2 times 2 times 3 times 3, or 2 to the 4th power times 3 squared. Let's make that into an exponent, all right? So we're looking for factors they have in common. If you look at both numbers, they both have, the 144 has 4 2's in it, which is equal to 16. And of course 16 contains 16. So 16 is the greatest common factor of 144 and negative 16. So what we're going to do is factor that 16 out of this binomial up here. So if I pull out negative 16, that leaves t squared minus, and I have to know how many times 16 goes into 144. Looking down here, it looks like 16 times 9 is 144, so it must be 9. So thinking back, what we just did was we factored out negative 16. Negative 16 times t squared is negative 16t squared. Negative 16 times negative 9 is positive 144. So we just factored that into a, it looks different, but it's the same expression. All right, moving on down here, what we should notice, so we factored out negative 16. What we should notice right now is that we've got the difference of two squares pattern right here. We have two perfect squares and the difference of those. So we're going to factor that out one more time. We get negative 16, and now this is the result of multiplying out the sum and difference pattern. So we're going to have a sum and a difference. The square root of t squared is t. Square root of 9 is 3. So t squared minus 9 factors into t plus 3 times the quantity t minus 3. So all we've done so far is we've factored out the right-hand side of the equation. We just wrote it in a different way. We broke it into its factors. If I multiply this by this and that by that in any order, I will get back to my original equation or expression, which was 16t squared plus 144. So now what I have to figure out, because this is set equal to 0, I want ground 0 for height, I just have to figure out what values of t would cause this trinomial to equal 0. Of course, negative 16 is a factor, but it can't equal 0. So we just need to look at these other two factors. So t plus 3 could equal 0, or t minus 3 could equal 0. We're using our zero product property now. So we're going to solve for t. If t plus 3 is 0, then t would have to equal negative 3. If t minus 3 is 0, then t would have to equal positive 3. So the negative, you can't have a negative number of seconds, really, in this situation. That doesn't make any sense. So you would disregard the negative solution, which means the time it took for the brick to fall to the ground would be 3 seconds after it falls. So this was an example of using our factoring skills to solve an equation that actually has some meaning. So now you have several remaining checkpoints to try this out on, and I'll let you do that on your own. We'll compare our results tomorrow in class.